So this was the project that I chose to do. It was on a 5-gallon system over at a nursery over in Upland. Some major components that were used in this 5-gallon system is a polyethylene tubing, a 1,000-foot roll. We call this spaghetti tubing. We also use a Schedule 40 PVC tees. Ends were connected to a Rainbird anti-siphon valve. Also use 1-inch Schedule 40 pipes for the laterals and connecting to outlets, as well as using spot spitters, specifically 90-degree brown mini flow. Here's just a picture of that polyethylene tubing. It's a 1,000-foot roll. It's pretty flexible and allows you to move on awkward slopes and surfaces. Benefits of using this tubing: like I said, it's rather flexible. You can use it on awkward turns and slopes. It's pretty corrosion resistant, and you can cut holes in it rather easily, which is really beneficial, especially when you're setting up close to 300, 500, 5 gallons per section. So you can start a new line and have your spot spitters set up. Benefits of using the Schedule 40 PVC tees: um, they allow you to split into two different lines, especially because they're most likely going to be a 90-degree angle. They're going to allow you to move down laterals or move vertically up and down areas. Its affordability makes it really a good ideal choice, in my opinion. It's important when you're first setting up a big project or anything, a nursery. Your budget can be something you're gonna look at pretty pretty specifically, and this is pretty affordable. It's also can withstand corrosive materials as well. Here's just a blurry picture of how we use the PVC T sockets, the Schedule 40. And you can see here it allows us to move down laterals and up and down the sides. This is a mini flow spot spitter, the 90-degree. Here I just included the chart of how at what PSI and what GPM it should be running at, or what the output and input should be. And this is a good chart to look at, especially if you're barely starting out and you don't really know how much PSI you're willing to lose. Here I also included the anti-siphon valve that we use. It's a Rainbird ASVF anti-siphon valve, 1-inch, 100-ASVF. Pretty good, pretty modern. So far, haven't seen too much problems with it. Here's just some other components that we also learned throughout our classes. It shows you the solenoid, the outlet where you connect you will connect like a male adapter here, and then connect your PVC pipe, and then start connecting your system out. And then here's the inlets, some bleed screws, the flow controls. Really looking at this this guide helps a lot. It'll help you understand getting a feel how to better run your siphon valve. And here, like I said, here's the outlet with the male adapter and your 1-inch Schedule 40 pipe, which eventually goes down into the ground and then comes back out this way, and then eventually connects to your spot spitter system. And here I just included another picture of how we run the laterals with the Schedule 40 pipes and how we run that around our section. Schedule 40 PVC pipe It's ideal because it can withstand high heat, especially being outside in California. You really don't want your materials to. You want your materials to withstand that high heat, that high summer, um, as well as handle your spot spitter system, handle the amount of pressure you're giving off within each zone, and it's rather inexpensive compared to things like Schedule 80, and it's rather reliable. You can cut it off and then replace it, or store it. If you buy extra, you know eventually you could use extra. It's really reliable and cheap. It also has a high impact strength, which is pretty important working out with heavy machinery. If you hit it, it might, I mean, most likely they do break, but you have a chance of not breaking it. Here's just a small clip of our small 5-gallon iceberg roses with the spot spitters running. And there you can just see how we're running that polyethylene tubing. Um, for the most part, this system it's been working well, but what I found is at the front you have good amount of pressure. In the middle you still have fair amount of pressure, and then closer to the end is where you start seeing more problems. You see that the spot spitters aren't throwing out enough water. They look really slow and really not too efficient for each 5-gallon. So for my recommendation section, um, I honestly thought there was too many spitters on the small diameter supply line. Like I said, at the end of the line, we saw less water running than the beginning of the zone. Um, he didn't have enough pressure, or his PSI planning wasn't running correctly because he didn't know how much PSI he was willing to lose. So what I recommended him to do, and I hope this is accurate, um, he can really he can upsize the PVC pipes because the amount of pressure he's running it on is too little, and with upsizing those PVC pipes, he can run with the amount of pressure that he's giving off and the higher PVC pipes, he can see a more efficient system, and then at the end of the line, he'll most likely have better flow or better water being put out more efficiently. Another option that I recommended him was to center feed the supply line with a T fitting so that he can make it into two supply lines with half the length and half the amount of spitters. And I don't know if this is accurately correct, but talking to other people in the industry, they said he can run the main line along the side and have more options or more flow for him. But I don't know how accurate that is. And that was the end.